Hello good day viewers. In this tutorial we are going to find a solution to this simple Olympiad mathematics question. The question reads, if 3 to the power of 9x is equal to 64 and 5 raised to the power of the square root of p is equal to 64, we are asked to evaluate the expression 3 to the power of x minus 1 whole to the power of 3 divided by the square root of 5 raised to the power of the square root of p. Alright, let's get started. I would like to take the first equation here, transform it in terms of this, which is our numerator, then transform this particular equation in terms of the denominator here. Let me start with the first one. Alright, here is the first equation, 3 raised to the power of 9x equal to 64 raised to the power of 1, because any natural number can be raised to the power of 1. Then I would like to divide this exponents by 3. Let's do that. So if you divide 9x by 3, you're going to obtain 3x. So this is 3 to the power of 3x. And this is equal to 64 raised to the power of 1 divided by 3, which is just cube root of 64. And cube root of 64 is what? 4. Therefore, 3 to the power of 3x is equal to 4. All right. Next, I would like to divide both sides by 3 to the power of 3. So we have 3 to the power of 3x divided by 3 to the power of 3. This is equal to 4 divided by 3 to the power of 3. According to one of the laws of indices, we can take a base here and subtract the exponents, 3x minus 3. And this is equal to 4 divided by 27, because 3 to the power of 3 is 27. Next, you can see that we have a common factor of 3 here, so we can factor it out. So to the left hand side, we have 3 raised to the power of x minus 1 whole to the power of 3. Once you expand this, you are going to have 3x minus 3. 4 divided by 27. So you can see that this is exactly our numerator, right? Which is 3 to the power of x minus 1 to the power of 3. So we are done with the top, which is 4 divided by 27. Now let us move to the other equation. All right, here is the other equation. We have 5 raised to the power of the square root of p equal to 64, but I would like to transform it in terms of the square root of 5 raised to the power of the square root of p. So how can we transform this 5 into a square root of 5? We can simply do that by multiplying their corresponding exponents by 1 over 2. So this is 5 raised to the power of square root of p whole raised to the power of 1 over 2. We do the same thing, 64 raised to the power of 1 over 2. You can switch this. You can take this one outside and bring this one in according to one of the laws of indices. So we have 5 raised to the power of 1 over 2 raised to the power of the square root of p. And this is nothing but, remember this is 64, not 6. Power of 1 over 2 is the same thing as square root of that value, right? So this is square root of 64. And this is square root of 5. So we have square root of 5 raised to the power of the square root of p. And this is nothing but 8, because square root of 64 is 8. So you can see that our denominator is 8. So now let us back substitute. Let me just copy this. So this is the expression. This is equal to the top, we have 4 divided by what? 27. Then we divide by the numerator, which is 8. And dividing by a number is the same thing as multiplying by its reciprocal. So this is 4 divided by 27. Multiplied by the reciprocal of 8 is 1 divided by 8. And 4 can divide 4 one time. And 4 can divide 8 how many times? 2 times. So all we have is what? 1 divided by 27 times 1 divided by 2. And 1 times 1 is 1. And 27 times 2 is 54. And hence, this is just the solution to this problem. The whole of this expression is nothing but 1 divided by 54, provided that these two statements are true. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Another way you can do that, though it is not Olympiad standard, You can solve for x from this equation, substitute it here, then solve for p here, plug it in here.